So I'm hoping everyone can hear me, yeah?
Yes.
Great. So welcome to the afternoon session, everyone. So this is the first session, and we do have a few more sessions in the afternoon. And we have two speakers. So the first presenter is Yixia Lu. And Yixia is a PhD candidate in materials engineering at the University of Southern Queensland Centre for Future Materials. She is part of the functional materials research team and is studying fiber retardant composites under her supervisors, Professor Pingyang Song and Professor Hao Wang. Yeah, Yixia, you can start sharing your screen and start the presentation.
Okay. Oh, okay. I think you cannot see my screen. So, yeah, welcome. Sorry, I'm fine. I'm looking for my presentation, the screen.
So the share content button should be at the top right corner.
Yes. Yeah, I found it. Can you see that?
Yep, perfect.
Yeah, we can see.
Okay. So, good afternoon, everybody. Thank you, Molly. Thank you, CFM. And thank you all for attending my presentation. I'd like to share my research. It's a great honor for me. My name is Yixia Lu, and I just want to share some research achievements of my study. So my topic is synthesis of PN-containing fire retardants and their applications in polyamide 6. So I'd like to introduce you the background of polyamide 6 and some literatures, and I'd like to share the research and the conclusions. So firstly, I'd like to introduce you polyamide 6. It is a classic plastic, and it is widely used in furnishing, electronics, electric equipments, transportation, buildings, and some other industry materials, as well as our daily life. Because of its it has so many advantages like excellent mechanical properties, durability, abrasion resistance, oil resistance. Take this car, for example. There are so many parts we use polyamide as the materials, like a charging infrastructure, high voltage connector, and battery, and the bus bars. So it is widely used, but it has a huge disadvantage. It is highly combustible. As the test parameter says, the limiting oxygen index value is between 22% to 24%. This is a little bit lower for materials, and it cannot pass the vertical burning test UL94, or it only has the V2 rating in the test. So the use of this material always gives rise to environmental pollution and threat to life and property, because sometimes heavy fire will happen. So as we talked about these two tests, I'd like to introduce you more about the fire assessment. First, we'd like to perform UL94 vertical burning test. There are 4 ratings here. regarding to the burning time, the number of specimens, the glue time after the second ignition, and whether the coating is ignited or not. So when the value is V0, the level is V0, it is much better. It says the material is safe. The second test is LOI, that means limiting oxygen indexed. For flammable materials, the value is lower than 21%. And for combustible materials, the value is between 21 to 26%. This is not safe as well. For self-extinguishing materials, the value is over than 29%. This is much safer. So we also use cone calorimeter test with so many parameters like time to ignition, heat release rate, and mass loss rate to evaluate the fire safety. So we'd like to explore some strategies to reduce flammability of polymers. For PA6, one is to synthesize intrinsically fire retardants by using in situ copolymerization with caprolactam or copolymerization of fire retardant monomer and PA6. The other one is to add some fire retardants into the polymers. So I'd like to show you this example of intrinsically fire retardant PA6 by using copolymerization reaction of this compound, and finally we got intrinsically fire retardants. This kind of method require lower content of elements, so it has advantage like good flame retardancy and lower count of the fire retardant elements, but it also has some disadvantages like challengeable molecular design to copolymerize with caprolactam properly. Also, during the synthesis, harsh reaction conditions are always needed, like high temperature, high pressure, specific facilities, abundant catalysts. Also, we usually find some signed products are generated in the reaction. So luckily, we often use the second strategy to improve the fire safety, that is additive fire retardants. We prepare these fire retardants independently and add them via a melt blending strategy. It contains several categories like phosphorus-containing fire retardants, nitrogen-containing nanomaterials, or other elements containing fire retardants. The typical ones are shown here, like ADP, AHP, DOPO, and DOPO derivatives are typical phosphorus-containing fire retardants, and MCA is the typical one of nitrogen fire retardants. Here, I show you some chemical structures of the current used phosphorus-containing fire retardants. The typical one is ADP, DOPO, and some DOPO derivatives. Also, I'd like to show you some several examples of nitrogen-containing fire retardants. It's always used with some other elements. For example, MCA is the traditional one with a large amount of addition into the polymers. And also, I collected some boron-containing fire retardants from the literatures. These slides show several PN-containing fire retardants. It means these fire retardants contain phosphorus and nitrogen together, and also sometimes we use them with other elements or compounds. So I collected some reported researches. For example, in this research they use ADP and the synthesized API to collaboratively improve the fire safety with a relatively low addition amount in glass fiber reinforced PA6. Another one also shows great performance by using ADP and the synthesized DES. So another one, because it contains phosphorus and alumina, so it is fantastic. And with 21% of addition, these two components passed with 0 rating and with no dripping. So another typical ones, doppel and doppel derivatives are also used in these glass fiber reinforced PA6. In my research, we focus on PA6, not glass fiber reinforced. But in industry, they often add glass fibers to enhance the strength and some other properties. This is another research by using doppel derivatives. For nitrogen-containing fire retardant, the traditional MCA is used, but as I said before, previously, they often use some other materials to use together to enhance the fire retardant together. And here there are two examples from the literatures. They use PN containing fire retardants. It shows highly efficient high fire retardants with high LOI values. And we can conclude that the PN containing fire retardants performs better than the sole use of phosphorus containing or nitrogen containing fire retardants, as they act mainly in condensed phase and gas phase together. So this is highly efficient. Talking about this, I'd like to show some the mechanism. I mean how the fire retardant work. For polymer without fire retardant, of course, there are volatiles, hydrogen-free radicals, and some gases, as well as water, are generated in the combustion, but there are less incombustible gases, and the chars are poor, so the polymers usually burst out. But for polymers with fire retardants, there exists heat transfer, phosphonate-free radicals quench the urea-free radical reaction, and also we can see much more char layers are generated on the surface of the polymers. So the mechanisms involved in this combustion include heat absorption, barrier effect. For example, the char layer as a barrier to isolate oxygen and the underlying polymer, and catalytic effect by the fire retardants, and promote carbonization effect, free radical quenching effect, and oxygen dilution effect. They both work in gas phase and condensed phase together, so the efficiency is much higher. So in my research, I'd like to use alumina diethylphosphinate, abbreviated as ADP, as the main fire retardant, because it is the main part of these commercial products and it is highly efficient. But the disadvantage is the price is a little bit high. So I'd like to explore some compounds to add with ADP together into PA6 and lower the amount of ATP so that the material's price can be lower. So I'd like to develop some PN-containing compounds as synergist of the current used ADP and investigate the synergistic effect between them. And also, I'd like to understand the correlation between chemical structures, composition, and the impact on comprehensive properties of PA6. Also, finally, we'd like to elucidate the fire retardant mechanisms of PN fire retardants in PA6. So my research is conducted into 3 parts. Mainly, we synthesize some PN-containing compounds as synergistic agents of ADP, and we use them with ADP together to enhance the fire safety and evaluate the fire retardants performance. And the current one research is adding boron element into PN system. So I'd like to introduce the first part. This research is published on the Journal of Composite Part A. In this research, we use melamine and ATMP as the starting materials with a molar ratio of 3:1 to synthesize MTP. And we also characterized the product. As we can see, it is a microplate appearance by using SEM. And we also investigate the chemical composition and microstructure. Next, we investigate the thermal stability by using TGA. From this table, we can see MTP is not as stable as expected, but dramatically, the residues are so high as 37% and 80% at 800 degrees. So it is supposed to create many, as much as expected residues to isolate the heat and oxygen. So in this research, we add the additives with total amount of 20%. We investigate the soil addition of MTP and soil addition of ADP, and also we set some formulas. So here we can see most of the composites leaves much more residues. We also investigate the vertical burning test and LOI values for these 2 composites with 8% of MTP and 12% of ADP, and the other one is 5% of MTP and 15% of ADP. These 2 composites passed with their rating with high LOI values. And we also investigate the contrast. We find for this composite, when MTP and ADP's amount of 5 and 15, the time to ignite is for 29 seconds. This is beneficial for people escaping the fire, and the heat release are decreased as much as 67% for PHRR. And we also evaluate the fire performance and synergistic efficiency of these composites. we find that for PA6 with 5% of MTP and 15% of ADP, the fire performance index is highest and the fire growth index is lowest. And this composite possesses the highest synergistic effect regarding to PHRR, THR, and EHC. The value is superior. We also studied the char layers. For the individual addition of 20% of MTP, the composite left a much swollen char layers with a huge hole here, and but for the other two composites, we just choose these three typical composites to show the char layers, because we have so many formulas, so many composites. So the typical one, we can see the char is intact and compact. But for this pseudo addition of 20% of ADP, from the SEM image, we can find so many holes in the internal layer. So it is not good as the composite in containing MTP. And we also investigate the fire retardant efficiency regarding with flame inhibition, charring, and barrier and protective layer. These parameters will find 5% of MTP and 15% of ADP enhanced the fire safety regarding fire inhibition and especially barrier and protective layer. Lastly, we investigate the mechanical properties. You can see here in this table, although the strength declined to a large extent, the tensile strength to a minor extent, it also declines, but the elastic modulus increased. So we can conclude that the addition of ADP into the addition of MTP into ADP based PA6 composites increased the mechanical property. So the second research is a bio-based PN containing compound. We use MA and phytic acid as the starting materials with a model rate of 6:1 in aqueous solution to synthesize this compound MPA. And we also explored the characterization. This material is much thermally stable than the previous synthesized MTP. So this is our improvement, the progress, I think. We also investigate the vertical burning test and the LOI values. These components, including 18% of amount of additives, they all possess a high LOI value over than 26% and passed the V0 rating. As the contester says, the heat release rate is also decreased. For this formula, with 4.5% of MPA and 13.5% of ADP, with the total addition amount is 18%. This formula presents the lowest PHRR values, with more than 40% of decline. And we also investigate the fire performance and the synergistic effect. Luckily, we found that MPA and ADP shows efficient synergistic effect. And this formula shows best. We also investigate the char layer. As we can see here, pure PA6 burns out after combustion. But for MPA and ADP addition composites, there are visible char layers here. And we also use SEM to explore the internal layer. So similar as the previous work, this formula of composite performs best with a high flame inhibition, charring effect, and barrier and protective effect. This work has been published in JMST, and we also explored the mechanical properties. We found the combination use of MPA and ADP improves the elastic modulus, and much better than the ADP doped PA6 composite, as the strain says. So the current research is adding boron element into PN system. We also employed melamine as the starting material. The boron element is from boric acid, and we also use ATMP as the starting as the one of starting material. This is also reacted in aqueous solution. We investigate by using FTIR, XPS, XRD, and SEM to characterize the product. MBA. Sorry, I forgot this to denote here. MBA. And at the thermal, at the TGA result says it is quite thermally stable. Here we can see from this table, we just add 15% of addition at the total amount. The soil use of 15% of MBA, and the other two component is 6% of MBA and 9% of ADP. The other one is 5% of MBA and 10% of ADP. This is the amount is close, but we find some difference between them. For vertical burning test and the LOI value, this table says the composite containing 5% of MBA and 10% of ADP perform best. Perform better than the other component, but 15% of ADP performs best, as the LOI value says. But the contest results is a little bit different. We can see here, for the combination use of these two components, the PHR and THR and EHC are decreased to a large extent, especially for 5% of MBA and 10% of ADP doping PA6 composite. These PHR values declined for 50%. We also evaluate the fire retardancy performance by using FPI, FGI, and FRI. This is calculated by this via certain equation. For this component, the polymers including 5% of MBA and 10% of ADP, and the performance is best. And this system, this research, we use the lowest addition amount, just 15% of the total amount, and they can achieve best performance on fire retardancy. We also investigate the mechanical properties. These results are similar to the previous work. So lastly, I'd like to give you a conclusion. 3-PN containing composites compounds are synthesized by using melamine as the starting materials, and we use aqueous solution in the reaction, and we find significant decrease of pH by using these compounds and ADP to improve the fire retardancy of PA6, and it is found that a fantastic synergism exists between the compounds and ADP. And also in the research, we explored the fire retardant mechanism. So lastly, I'd like to thank UniSQ and my supervisors, Professor Song and Professor Wang. They support me so much on my research. Thank you. Thank you for your attention. And any questions?